Okay, these next problems are a little different. It talks about another rule that we have in math where you can't leave, it's kind of like a rule I have in math is if my answer was 10/12, I would not leave it as 10/12. I would go ahead and factor it to 5/6. So reducing is one of those rules where it's just understood. If you have a problem that will reduce, you're going to reduce it. Same thing happens with radical problems. If you see a problem that has a square root in the denominator, that is not the proper way to leave an answer. So I have to find a way to get rid of a square root. The only way that I know to get rid of square root is if I have something like square root 36. I have a perfect number under there. And what makes that a perfect number is the fact that it's 6 squared. So if I want to try to get rid of square root 7, I'm going to have to multiply this by the big one. Because I can multiply any number times 1 and I haven't changed the number. Now, also 1 can be any fraction over itself. So I'm going to be really choosy on this. I can either call this the big one or the well-chosen one. I want to choose something to put there that would get rid of a square root. So instead of a 1, I'm going to put this. Square root 7. I'm going to multiply that by square root 7 over square root 7. So square root 7 over square root 7 is 1. So I haven't changed the problem. But watch what happens when I multiply. On the top, I'm going to get 5 square root 7. But on the bottom, I'm going to get square root 49. And the square root of 49 is 7. So my answer is 5 square root 7 over 7. And this has solved the problem of having a square root in the denominator. Let's do another one like that. See how this one has an issue? You're not supposed to leave an answer with a radical in the denominator. So I'm going to multiply the big one, or the well-chosen one. I want to choose something that will get rid of a square root in the denominator. So I'm going to multiply this by the square root of 2 over the square root of 2. Because now I have on the top negative 8 square root 2, and on the bottom I have the square root of 4, which is just 2. So what happens is when you do this, when you multiply it number times itself, it's just going to give you that number without the radical sign. And now this one will reduce and go to 4. So my answer would be negative 4 square root 2. This is called rationalizing the denominator because you're getting the radical out of the denominator. The next problem, the first thing I would do is I would split it apart to square root 7 over square root 10. And then I would try to think, is 10 going to simplify? And I don't think it will because 10 would be 2 times 5 and you wouldn't have the same number under there. So I'm going to rationalize the denominator. That means I'm going to get rid of the radical in the denominator by multiplying by the big one. In this case, the big one needs to be the square root of 10 over the square root of 10. So on top, I get square root 70. And on bottom, I get square root of 100, which is just 10. So that's my answer. Okay, we'll do a couple more. If you want, on these, try to pause the video, work them yourself, and then unpause the video and check them to see if you're right. All right, hopefully you did it this way. I would split this apart to square root, I'm going to write it down here, square root of 25 over square root of 3. And I know what the square root of 25 is. It's 5, so I'm going to mark that off and just put a 5 on the outside. And now I want to take this times something that will get rid of the denominator, the radical in the denominator. So I'm going to take it times the big one. The well-chosen one is going to be the square root of 3 over the square root of 3. So on the top, I have 5 square root 3. On the bottom, I would have square root 9, which is just 3. Last one. This would be square root 3 over square root 5. So I'm going to multiply by the big one, or the well-chosen one, and I'm going to choose square root 5 over square root 5. So on top, I get square root 15, and on the bottom, I get 5. Notice this does not reduce because the 15 is under the radical, and here the 5 is not under the radical. This number is approximately 4, just a little bit less than 4. We know that 4 and 5 would not reduce.